In this lesson, we're going to look at how we rationalize radicals. We're going to first examine what it means to rationalize radicals. We're going to understand conjugates of radicals, and then we're going to look at how we can use these conjugates to rationalize radicals. We rationalize radicals to remove the radical from the denominator of a fraction that has radicals. And rationalizing is only necessary if you have a radical that cannot be simplified in the denominator. So let's look at these examples here. Which of these do you think we need to radicalize? Here, in this case, the denominator is 1, so we don't need to radicalize this. Now look at this right here. We have a radical, but it can be simplified to square root of 12 over 2. So this doesn't need to be radicalized. It doesn't need to be rationalized. Now look at this right here. We have square root of 6 minus 8. We have a radical in the denominator, so this must be rationalized. And then in this case here, look at the denominator. We have square root of 13 minus square root of 5. The square root of 9 is 3 plus square root of 10. The presence of this radical means we have to rationalize this denominator. So this also must be rationalized. Now let's look at the conjugate. So what we do with the conjugate is we look for another expression that we can multiply the existing expression by, another radical expression that is, that would somehow get rid of the presence of radicals. And what we found is, when you look at, there is a special case of binomial multiplication, and what that case is that when we have a plus b and we have a minus b, we can safely do a squared minus b squared and know that we have the right answer. So here, because the radical here is a square root, so we just, if we take a square of the square root, we get rid of the square root sign, which is the radical sign. So what we end up always having to do is we have the same type of an expression, only that we change the sign between the expressions and the radical. So here, for example, we have 3 plus square root of 5. What we're going to end up with is 3 minus square root of 5. So you see, nothing really changes except the sign in the middle right here. What about this one here? Square root of 5 minus 6. We end up with square root of 5 plus 6. So we change the signs, and if you multiply this together, you will find that we do not have a radical anymore in the result. So let's look at these other ones here. The radical here, we have square root of 2, square root of 7. This is the approach I typically like to use. I write the expressions, and then I just change the sign. So here, square root of 5, square root of 10. This is minus, so I just change the sign, and that's your conjugate. Now let's look at how we're going to rationalize these radicals. The first thing we want to do is identify the conjugate. So what's the conjugate of the denominator here? Remember the trick here, we have square root of 3 and we have 7. This is a plus, so I'm going to use the opposite sign. So that's the conjugate right there. And then we multiply the numerator and the denominator by the conjugate. So we multiply this by square root of 3 minus 7. And we multiply the denominator also by square root of 3 minus 7. You can see that this ends up being equal to 1. The idea with this is to make sure that when we're multiplying by an expression, the expression gives us 1, because any number of fraction multiplied by 1 ends up making sure that the fraction or the number is unchanged. And that's what we're trying to accomplish here. So this is going to give us square root of 7 multiplied by square root of 3 minus 7. divided by square root of 3 plus 7 square root of 3 minus 7. Remember this, a plus b, a minus b is equal to a squared minus b squared. So let's look at the numerator. Square root of 7 multiplied by square root of 3 is square root of 21, which is 7 times 3, minus 7 square root of 7. This is divided by square root of 3 squared. Let's go ahead and show it this way. Minus 7 squared. So this is going to give us square root of 21 minus 7 square root of 7 divided by 3 minus 49. So this is going to give us square root of 21 minus 7 square root of 7 divided by minus 46. Can you see now we have removed the radical from the denominator? So this is, we can safely just put a minus sign out here, and then we have square root of 21 minus 7 square root of 7 divided by 46. So that is the rationalized version of that radical. We're going to apply the same method here again. We have square root of 5 plus 9 divided by square root of 5 minus square root of 3. We're going to identify the conjugate of the denominator. So we have square root of 5, square root of 3, and we just change the sign. Now we multiply the numerator and denominator by square root of 5 plus square root of 3, square root of 5 plus square root of 3. So this is going to give us square root of 5 plus 9, square root of 5 plus 3, plus square root of 3, divided by square root of 5 minus square root of 3, and then square root of 5 plus square root of 3. So now we're going to apply FOIL. So look at square root of 5 squared. That's first. O is going to give us plus square root of 5 square root of 3, then plus 9 square root of 5, and then plus 9 square root of 3 divided by square root of 5 squared minus square root of 3 squared. So we have square root of 5 squared is 5. Square root of 5 times square root of 3 is square root of 15. 9 multiplied by square root of 5, that's 9 square root of 5. Then 9 multiplied by square root of 3, 9 square root of 3, divided by 5 minus 3. So this is going to give us 5 plus square root of 15 plus 9 square root of 5 plus 9 square root of 3 divided by 2. And that is the rationalized version of this radical. Final example, we're going to look at the conjugate first. The conjugate here is, we're going to write square root of 11, we're going to write square root of 13, and we're going to use the opposite sign. So now we're going to multiply numerator and denominator by the conjugate. So square root of 11 plus square root of 13 over square root of 11 plus square root of 13. So this is going to give us 12 square root of 11 plus square root of 13 divided by square root of 11 minus square root of 13 and then square root of 11 plus square root of 13. So this is going to give us 12 square root of 11 plus 12 square root of 13 divided by square root of 11 squared minus square root of 13 squared. Now this is going to give us 12 square root of 11 plus 12 square root of 13 divided by 11 minus 13, which is going to give us 12 square root of 11 minus 12 square root of 13 divided by negative 2. So what we can see here is we can divide each of this term by negative 2. So we have negative 6 square root of 11 plus 6 square root of 13. So this is how you rationalize radicals.